this lecture, we're going to go over Node.js errors and error types, and then we're going to create a sample error within our application and then reinforce our application with a try-catch that will allow us to handle that error in a graceful way. Before we jump into that, let's go over how Node thinks about errors. Broadly speaking, Node.js errors work very similarly to any kind of JavaScript error. They are a class that have different types, like eval error, syntax error, etc. As you've been seeing me debug this application in these lectures, you've seen different kinds of errors get thrown. Many of the ones that you've seen have been system errors, which happen when we're trying to open a file that doesn't exist, etc. And today we're going to be dealing with user-specified errors. Those are ones that we define as part of the application and throw ourselves. So let's go ahead and open up our server, and down at the bottom we're going to define a new route that calls a handler that is designed to throw an error and crash the application. So I'm going to add a route to examples/error, and that's going to route to handlers.exampleError. I'm going to open up our handlers file and start crafting this. I'm going to do it down at the same level as the JSON API handlers. This is going to be called example error. Handlers.exampleError, and it's going to be a function like any other. Now, the reason we're building this handler to throw an error is to go over the real-life scenario where you've built the scaffolding of your application, and the scaffolding is pretty rock solid, but over time you add more and more handlers, and it's only a matter of time before one of your handlers has an issue. So within this example error, we're just going to create a new error. So we're going to say var error equals new error. And the error class is available globally. You don't need to require it. But when you create a new error, you get to define what's going to be thrown when that error is thrown. So we're basically giving it a name, and I'm going to say this is an example error. Now that the error exists, we want to throw it. So we're going to throw error. I'll start up the application now. Then we'll go over to Postman and call this route, example/error, and see what happens. All right, so I'll enter localhost 3000/examples/error, send off the request. You can say we didn't get any response, likely because the system crashed while trying to produce a response. So if we go back here, yes, we can see that at handlers.js at line 385, which is right here, we received this error. This is an example error. So that is how you throw errors and get it to show up at a certain line. But let's say that we built this handler and we can't really diagnose what is going on. Either we don't have time to diagnose what's going on, or what's going on, the error that's being thrown is deep within some library, and we've opened a support ticket for the library, but who knows when they'll get back to us, etc. And so we need to reinforce our server infrastructure so that this handler can throw this error as they're doing without taking down the whole application. Because as you see, the application is dead now. It's not going to accept any more requests. The thread doesn't exist. So let's go back to server.js and look at ways that we can reinforce where we call this handler so that we call it in such a way that it can't do anything to take down the application. Let's go back over this unified server for a moment. If you remember, this is a function we built early on. It gets all the properties of the request, like the URL, the path, the query string object, etc. Once the request is all gathered up, it chooses a handler and then routes the request to that handler. So this actually looks like a good point to jump in and try to intercept any thrown errors before they crash our thread. So the first thing we want to do is move all the logic inside of the chosen handler callback to its own function. So I'm going to copy everything inside of these brackets. I'm going to cut it out And then I'm going to define a new function here that is to process the response from the handler. We're going to call this server.processHandlerResponse, and it's going to be a function that takes in the response, a method, a trimmed path, a status code, and a content type. Then inside of here, I'm going to paste everything I just got, which means inside of the chosen handler callback, what we need to do now is, rather than running through that logic ourselves, we just need to call server.processHandlerResponse and invoke it with res method, trimmed path, status code, payload, and content type. Looks like I actually forgot to include payload down here. Okay, what is the difference between invoking all this logic directly or invoking it inside of this function? So far, nothing. These two ways of handling these issues have the exact same effect, except that now that this is slimmed down, it's easy to wrap it in a try catch. So we're going to wrap it in try, and then we're going to catch any exception that is thrown while that handler is being called. And when we do catch an error, for example, if this handler threw this error, we can log it out by calling debug e. And remember, we've defined debug above. So that will log it to the console. And then we can continue on calling server process handler response, but this time we'll call it with res method trimmed path. And then rather than the status code that came back from the handler, we can call it with a 500 to let the requester know something really bad just happened and it crashed our server, or at least it would have crashed our server if we hadn't have caught the response. So we're going to call it a 500, and rather than returning any payload from that handler, since that handler crashed, we have to create our own payload. So we're going to create a JSON object called error, an unknown error has occurred. And then we want to make sure that they know that the content type for this response, no matter what you were trying to request, the content type for this response is going to be JSON. So let's start the app back up and then go to Postman and make that request again. Now we send the GET to the same route, but it returns back. It returns back with 500 internal server error. It sends us this message saying an error has occurred, but the app is still alive. Nothing has crashed. We don't even have anything in the console telling us that it crashed because we started the app without the node debug flag. If we start the app with the node debug flag, node debug equals server, node index.js, and then make the request again, we get the same response, and we can see the log saying this is an example error has been thrown at handlers.js 384, which is close to right where we threw that error. But as in the last case, the application is still alive and it can take this request over and over again without actually dying. As we told the server to print out non-200 codes in red, these 500s are coming back in red. So that is one way to bulletproof your handlers, or at least bulletproof the way you call them, so that there's nothing a developer could do really to crash the app from within a handler. Now, unfortunately, in the wild, many of the errors or issues that you encounter are going to be a lot more complex than a line in a file simply throwing an error. And so in the next lecture, we're going to go over using the debugger in detail so that you can understand how to walk through and step through your applications in real time. So let's move on to the next lecture.